Welcome back to part 2 of function transformations. As you know, it can take a very long time to create graphs of functions by hand if you must compute a table of values. In many cases, what is required is the ability to sketch the shape of a graph to see overall trends and locate important features, like local extrema, that we can ask a computer to calculate more precisely. The goal of this section is to identify patterns in function formulas that make sketching a graph easier. If we look at the functions below, we have the sketch of a linear function, and remember that b represents the y-intercept. We have horizontal functions, where you would have y equals some constant, like, say, 5, and you get a horizontal line. We also have power functions. Remember that even exponents produce upward-facing parabolas, and odd exponents create functions that approach negative infinity as the domain approaches negative infinity, and positive values as the domain approaches positive infinity. This will be true of functions raised to an odd exponent, such as 3 or 5, and the even exponents will always produce open parabolas. The higher the power of the even exponent, the more flat the parabola will become at the origin. If we look at root functions, we have something similar to what we just looked at, but this time the function approaches positive infinity. The domain of an even root is always greater than or equal to 0. The domain of an odd root is negative infinity to positive infinity. As the root's even index increases, the shape of the curve flattens out and becomes more vertical near the origin. Reciprocal functions look like they're about to touch the origin and then swoop up toward the vertical axis in the first quadrant, and they also do a mirror image in the third quadrant. This is because you can never have 1 over 0. So there is a vertical asymptote at x equals 0. The same idea is true for 1 over x squared. Again, there is a vertical asymptote at x equals 0. And finally, we have the absolute value function, f of x equals the absolute value of x. What this does is it takes the standard function f of x equals x, and it says all we are interested in is how far we are from the origin. We are not so much interested in whether its value is positive or negative. So anything to the left of 0 as an input, a negative value will be given as a positive range value. It may seem a little overwhelming to memorize all these different shapes. However, I would strongly recommend you take a little while and just get a few blank pieces of paper and sketch the general shape and the corresponding function for each one of these graphs.